going to do is gather some different ways to transform our graphs. So what this will come through as are these different numbers that are next to our function notation, and then eventually we'll have them in our actual functions that we're looking at. But what we want to be able to do is essentially read the function. Looking at just the description of the function, how can I tell how it's going to move? Like left, right, up, down, how is it going to stretch? Stretching upwards or stretching across. So what we're going to do in these videos is start to recognize those different pieces, and then we'll have a video putting all those pieces together. So where we're going to start is a vertical shift. So vertical is the idea of up and down. So what we're really changing here are the y values. So we have an example here where we have a table, and what we're going to do is just see what happens when we have this transformation of adding 4 to f of x or subtracting 2 from f of x. So let's just focus on the f of x plus 4. What this means is that we'll take our output value and add 4 to it. So what I'm going to do is go across the table, and where I see the different f of x values, I'm going to take each of those and add 4 to them. So what I'll do is 7 plus 4 will give us 11, 10 plus 4, 14, 13 plus 4, 17, 11 plus 4, 9 plus 4. So all we did was add 4 to the outputs. Now let's see how that changes our graph. So we have our original function f of x right there. What I'm going to do is change the outputs. So when I'm at x equals -3, I want to graph the point of y equals 11. And when I'm at 0, I want to graph 14. So what I'm getting are these new coordinates of a graph based on this transformation. So at -3, we'll be at 11. At 0, 14. At 3, 17. At 6, 15. And at 9, 13. And then what I'll do is go ahead and connect those dots. I don't have a ruler with my tablet here, so you should use a ruler at home. I will make these as straight as I possibly can. Okay, good enough. So what we can see is our graph moved upwards, and it moved up 4 units. So that's the transformation that's occurring here. We have this vertical shift. So with the shift, the graph itself doesn't change shape at all. Like if I had a cutout of my function here, I don't need to change that cutout at all, meaning it's not stretching across or it's not stretching upward in any way. It's holding its shape. All we're doing is moving everything up 4 units. So this moving up of 4 units is coming from this f of x and that plus 4 on the outside. Now let's see what happens when we do -2. So with -2, I'm going to take all of my original f of x values from my table and subtract 2. So I'll have 7 minus 2, 10 minus 2, 13 minus 2, 11 minus 2, 9 minus 2. So now I have these new coordinates where I have x is -3, y is +5, 0, 8, 3, 11, so on and so forth. So I'm going to graph those coordinates. So -3, +5, and 0, 8, there, and there. And then I'm going to connect those dots as best I can. Now, with this graph, what happened is the same idea. It's that our function itself didn't change shape. All we did was pick it up, and we moved it down 2 units. And we do that to every single point on our function. So even a point that wasn't as clear before, like this point right here on our function, that also moved down 2 units. So we get this overall shift down 2 units, and it's because of that minus 2. So our general rule here for vertical shift is that what you're going to see is your function notation plus or minus some value. If that value is positive, so if k is more than 0, then it's a shift up. So you're moving up that number of units. So when you have addition, it's movement upwards. If you have subtraction, which would mean k is negative, then the direction is down. So let's practice that real quick. So here we have our original function, and then we're just going to move this function around. And if it helps, you can draw the original function on your graph just to see where you're starting. So I'm just going to outline my original function there, and I'm just going to use dots so that it doesn't look like my final answer. So I have my g of x, and then I'm doing plus 2. So how I will translate that would be that we're moving up 2 units. So with your original graph, it helps to grab the key coordinates. So I'm going to grab those key points there, even that open circle one, and I'm going to move each of those points up 2 units. So I'm going to go up 2, up 2, up 2, up 2 with an open circle, and then since it's just a shift, we have the original shape. And then when you're making your graph, what can help is definitely use a pencil here because we don't want to actually have the original function there. I'm going to show them so that you can see the process here, but your answer should be this final graph there. Okay, this next one, so I'm going to just kind of lightly draw on my original function. I just need to make sure I do it correctly. Yeah, 2, 2, 3, 4, there, and there. Not quite, a little bit further. Okay. That's a very important piece, is drawing the original function correctly. Okay. So here's our original function, and what we're going to do is take our original function and then subtract 4. So that tells me we're going to move down 4 units. So, new function, I'm going to take that coordinate right there and go 1, 2, 3, 4, and then I'll do that to each of the pieces. So moving down 4 units. And then we have our final function. There we go. Alright, this next one, you can see there's a plus 2 and minus 3, and you might start thinking, okay, I'll move up 2 and then down 3, which you absolutely can, and we'll get to a point where we're layering on these transformations. However, you can just simplify it, and that this is the same thing as g of x g of x, and then 2 minus 3, which is a negative 1. So really we can just do one movement here instead of up 2 and then down 3. You'd end up at the same spot, but we want to simplify first. So we're going to move down 1. So if I have my original function, and then I'm going to take that down 1, 1, 1, 1. And there's our transform graph. So there's our vertical shift moving up and down, which will come through as addition or subtraction on the outside of the function.